will share the screen. All right. I will share the screen. Okay. This one is a link to YouTube if anybody's interested. And I will start the recording. All right, cool. So welcome to the IBC community call. Today we have Garbit from Electron Labs joining us to talk about CK IBC. So yeah, let's try to go through the updates and then have enough time for his presentation and discussion. So Susanna, you want to kick it off with the product updates?
Yeah. So I guess maybe this is more of an open question, and if anyone is willing to give their thoughts, feedback on this, but we have observed that it's been kind of difficult to get the middleware used in production for various reasons, because you have to renegotiate your channel version, and also channel upgradability is linked to v8.1. So I guess the open question was, I guess there's two parts. Is first, do people still see the lack of relayer incentivization as a problem? And then secondly, can we solve the problem in a simpler way? And I guess one option would be to solve it just for transfer, putting some kind of tip directly in transfer. So this is like an open question. If anyone has an opinion, please, share it now. Or if you don't want to share it on the call, feel free to send a message. So yeah, anyone have any thoughts?
Yeah, quick thought. I don't see Dean here, but to speak to a concern that he had, I think when I first started joining these calls many years ago, that he was concerned about doing anything special for transfer would make this more like a dedicated transfer protocol rather than a general packet forwarding protocol, and that sets us up differently, sort of in the eyes of regulation.
Yeah, I think we had the same concerns as well initially, but part of it was like this facing the reality that 90% of token packets are transfer. I haven't thought about the regulation angle though. I remember very early we had done some looking into relayer incentivization, whether that was like a money transmitter issue. I don't know if making something explicitly for transfer would change that at all or not.
Yeah, and I don't know if there's been more clarity on the regulations or not, but that was that's what this brings up for me.
I remember Charlie telling me that Interchain paid for legal advice on the issue or something, but this was before I joined, so I don't know the details, but I think that concern was Because I think the concern would apply also to fee middleware if you use it in combination with transfer, or are you saying the distinction by having something that's generic for all applications would change that concern?
Yeah, I guess in that case, the relayers don't really know or care what the application data is.
Okay, but then if it's applied to transfer specifically, we would.
No.
Oh, yeah, Luca, go ahead.
Yeah, just a question. Is this solution supposed to be some kind of temporary solution which would come faster and then until like channels are upgraded and ICS 29 is used, or is it supposed to completely replace the ICS 29?
Yeah, I think it would just be, well, it at least for now, maybe it would be in ICS 20v2, which would still be an upgrade feature. I don't know if it would be. I mean, we could hack it into ICS 20v1, but like I think that already exists for chains to do if they wanted to, as it stands, and no one seems to have done it for themselves. And if we did it for them, I'm not sure.
Neutron have.
Neutron have? Okay.
Yeah.
Do they take like a percentage of the received token, or how do they?
I think you have to pay an additional fee, like on top of the receive, as in on top of your fee that you want to send.
Right.
It's like a relay incentive, like API equivalent. It's just on the neutron.
Yes, I remember. Yeah. But no one has taken a cut of the transfer packet and sent it to the relay or anything of the sort. Yeah. Yeah, so I think it's less about like the code is already available and the upgrade is already available for incentivization. It's just a question of like adopting the feature, and perhaps this is like maybe a lower ask for people to adopt. Yeah. Adi?
On the legal angle, I do recall being part of some discussions, though I don't remember details. I think, yeah, if I'm not mistaken, I think the legal advice that we got was that the design of the protocol should not assume that you are going to nominate a specific wallet that is going to be responsible for the relaying, because that would make that wallet liable to the money transmitter or something like that. So I think it was more of a technical design of how should the protocol work. Is the protocol going to reward with fees the relayer before or after the relayer does its job, or something like that? And I think the conclusion was, no, you're not supposed to reward the relayer before, and you're not supposed to nominate the relayer before. The relayer should only be paid after it does its job, and you cannot really restrict who are the wallets that can do relaying and who are the wallets that can be rewarded. That's what I recall from the legal front. Then the actual thing that I want to mention though is, I'm not sure I understood the question. Would it be simpler if relayer incentives just supported for transfer? I think if the question refers to the API changes that chains are supposed to, the chain developers are supposed to intake to upgrade, then the question is quite straightforward. You know, like the last breaking changes that they have to do, that includes Go API changes. If it didn't need channel operability, if it didn't need Go API product changes, like the more simpler it would be. So to me, the answer is straightforward, but I'm not sure I understood the question.
I think I've worded the question quite badly. I think what I mean is, because right now fee middleware is generic for all applications, but I'm wondering if there could be a simpler solution which uses the fact that transfer is moving tokens from A to B to just take some amount of those tokens and use that to directly incentivize relayers. And I guess that, yeah, it's like if this could be, I guess that it's like, you know, is it just because people haven't upgraded to V8 that people haven't prioritized having fee middleware used in production, or is it actually like people will get to V8 and it's still a bit requires a lot of coordination overhead to actually enable the feature?
As a user of the software though, like Relay is essentially free.
Yeah. But I think it's also like problematic when you speak to people not within Cosmos about using IBC and you're like, and they're like, one of the questions they often ask, like, okay, who's paying the gas fees? And it's like the relay, and it's like, who's paying the relay? And it's like, well, yeah, like ... it's like kind of up to chains to decide on that. Whereas in all the other like ecosystems that use bridging, it's completely normal for you to pay fees to bridge, so it's like, and then my question is like, is this problem really solved in Cosmos, or are we just like say, okay, it's always going to be this, like, open question? But
I'm guessing that this conversation has come up because of the work on V2 of ICS 20, right?
Yeah, just wondering if like it should be solved another way. Is it still a problem? Do people still
I think it's too early to really tell. Cosmos has a dependency problem, and we haven't really seen people even adopt the latest versions. So like, I just don't think that there's any really data to really say one way or another.
But then by people not adopting the latest versions, it's saying that the features in them aren't compelling enough for them to want to upgrade.
I don't necessarily even think it's that. I think it's just the upgrade path for certain teams is complex, and nobody wants to be the first one to do it. I think that there's like a lot of circular dependencies, and also if you haven't stayed up to date with certain versions, like if you have to go from SDK 45 to 50, teams are a little worried about that. At least that's the kind of like impression I've got from working with other teams who haven't upgraded. But yeah, just my 2 cents, I suppose.
Yeah. So on the provenance side, we've thought about the fee middleware. We haven't put like any serious like thought into it, like, oh, we're going to use it for this, this, and this, and these are the fees we're going to charge and stuff like that. It's just kind of like a background thought. We haven't put more serious thought into it because of right now we're upgrading to SDK 50, and that's a lot of work. So we're trying to get through that before we actually think about like additional middlewares that we want. Even with IBC V8, we had to upgrade to SDK 50. So there's a lot of background work going on here, but we are thinking about like the fee middleware. It's not like, oh, this is garbage and we're just throwing it away. It's just we got a lot of other stuff to do first.
Yeah. Okay, there's 2 hands up. Ian, do you want to go first?
Sure. Just from the Relay's point of view, we get rewards from being validators, foundation delegations, and typically that is how we get our revenue. So it's not necessarily direct and via fee grants. And frankly, there's no incentive for the chains to change. So there's no incentive, if you go to version 8, you have to still enable it on the chain. If there was something where it came on by default and they had to disable it, so with version 9, you basically flipped a switch and then everything worked that way, then that might be a better way of doing it. From the relayers are fundamentally powerless in these negotiations. The chains basically decide, and then they say, well, if you want foundation delegations or whatever, then you need to turn this on. So it's a loss. It's a loss. Now, the work on Cosmos chain, where they basically formed a fee grant group, and those kind of things help. Back on Luna V, whatever, 2 years ago, there was actually chain proposals to reward relayers to repay them that way. Now, in an ideal world, if it was starting from scratch, yes, you'd have the transaction to pay for it. But I think people have the expectation now that it's free. So it should be like the chain. If you want to have relaying on the chain needs to pay for it in an ideal world, and probably transaction costs plus a tip. But that has to be built in the chain software as opposed to the channel definitions, and it has to be something by default or something like that.
Yeah. Thank you. And Jim, you've got your hand up, sure.
Yeah, just seconding the notion that the Cosmos SDK upgrade is difficult for a lot of reasons. We find the features compelling in IBC Go. We would like to get there as soon as we can. It's just a lot of engineering work to get there. So don't read lack of upgrade as lack of desire for the features.
Okay, that's reassuring. Thank you for that. But yeah, thanks for the discussion. It was great, but I won't take up the whole call. So yeah, we can move on. I just dropped a couple of blogs there from the past month, but yeah, Carlos, you can cover the rest.
Cool, thanks. So from IBC Go and specs, last Friday we released the patches for the security vulnerability. There's a link there to the security advisory, so you can read all the details, the full disclosure of the issue. Yeah, if anybody has questions, yeah, feel free to reach to us. Yeah, and besides that, yeah, the last couple of iterations, we were focusing on the POC for OP-Stack integration. We completed phase 1. Colin wrote a comment in the issue. I added the link with the outcome, and yeah, in this quarter, in Q2, we will continue with phase 2. For B8.3, we implemented queries to ICA. We added queries to ICA. So now you can use Interchain accounts to query the host, and you will get the response in the acknowledgement. We plan to backport this feature to the V7 release line. Yeah, we've been working on RollKit integration. So yeah, conditional clients, Celestia DA Lite client, the custom wasm contract for RollKit Lite client. Then also for V9, yeah, we've been working on the O2 client routing refactoring. So yeah, the work that we initiated already a couple of months ago with a POC by Damien and Colin, yeah, to decouple routing at the O2 client level from the encoding structure of the client state. So we merged the POC branch. We have been working on follow-up improvements. Aditya has opened a PR. I have the link there. I added the link with the changes to ICS20 to support path forwarding. So if anybody is interested, yeah, please take a look. And yeah, for the next couple of iterations, yeah, we will continue working on the custom wasm contract for RollKit. Yeah, hopefully we can start doing some integration testing with the Hermes, with the relayer to support, yeah, the RollKit integration. Yeah, we're gonna be working on adding support for dependency injection in IBC Go in V9, and working on ICS20 V2. Yeah, the first, let's say, feature of V2, which is the support for multi-token transfers. Okay, cool. So that's a bit the update. Any questions? All right, if not, then we can move to informal IBCRS. Maybe Adi, you will take this one.
Sure, unless you tell me that there's too much background noise. I'm just going to read the updates that I listed there, and then I'll talk about Hermes. So on IBCRS, there's actually, I coupled the Hermes SDK also here. On IBCRS, we have two broad updates. One is the releasing of V051. The main thing were some changes to the implementations of 24 and 02 and 07 standards. And this was mostly to be able to make the development client state verifier a bit more, let's say, ergonomic to be used in other use cases than the way it was currently used. I also put there the link to the full change log, but basically was just a small shard. And then on the sovereign integration, and this includes both Hermes SDK progress, which is code-based that is different from the Hermes mainline, and also sovereign IBC module work. So there I have these 4 bullet points about the connection in it between sovereign and Cosmos side. I also put the PRs. The updates are quite technical, by the way, so a bit low level. I also removed some of the other ones. And we also reorganized some crits. And then the last 3 bullet points, ability to access rollups current height and time in some RPC methods that we identified as necessary, emitting of some events, and last CV contract operational for the sovereign lecture. I'll pass it on to you.
Thank you, Adi. So Luca for Hermes.
Yep. So there's not much we update. We've finished planning the next release, 1.9, which will have the channel upgrade. So we'll be working towards that one.
Cool, great. If you have maybe like an RC candidate, can you share with us, and then we can run our end-to-end tests if you want?
We still don't have the candidate at the moment. I'm sorry.
Yeah, whenever you have it, yeah.
Oh yeah, sure. I'll ping you as soon as we have a candidate.
Cool,
Thanks.
great. Thank you. All right, then from a Stanislav team, Justin. For
Yep. Not a big update here on the relay or interchain test, really. We've had some substantial staffing changes, which people have just kind of been pulled over to other projects. As far as the relay goes, it's really just been a couple of small changes that people have reported to us either directly or via GitHub. We've pushed a fix for a broken wallet balance metric, where it was updating the wallet balance even when there was a failure. So it was showing like a inflated balance as far as metrics go. We've also updated the penumbra provider implementation to account for new changes in their protos. And then we've just added some better logging. We've had a few reports that on failures or warnings, there isn't really great insight into what chains or channels those failures were occurring on. As far as interchain test goes, we have finally landed support for comment mock. So it's an opt-in feature. You can configure it. I think there's some docs in the repo. It does increase the runtime quite a bit. So there's a substantial performance increasement there. Other than that, we've been working with some of the team working on interchain security and trying to land some features so that Gaia can move over to interchain tests for their end-to-end tests. So that's included being able to specify different genesis and self-delegations amount, and also the ability to specify the gas price for GenTX. And we're just working with that team to get anything in place that they need to completely migrate over to interchain tests.
Great, thanks. Any questions for Justin? All right, if not, we move to Penumbra and Irwan.
Yeah. Hey, everyone. So today's update is pretty short. We're basically putting a lot of effort in assurance and relayer integrations. So both in Hermes and in Relay, like Justin just mentioned. And yeah, hopefully we'll have more to announce soon. TM. But that's all for today.
Cool, thank you. All right, then next would be the presentation by Garbit. Is there any other topic that maybe we can spend like 5 minutes to discuss now, or we can leave it also at the end of the presentation? If we're fine, we can move to the presentation. Okay, cool. Then Garbit, the floor is yours. You can share the screen. So I will stop sharing.
Hi guys, hi everyone. Can you guys see my screen?
Yes.
Yes.
Let me just park this. Yeah. Okay, so thanks a lot for this opportunity, guys. It's actually wonderful timing for us. We are about to launch something very interesting. and it's kind of due in the next couple of days. So this presentation kind of lines up with that very, very well. So again, thanks for this opportunity. So just you guys can continue to hear me, right?
Yes, we can hear you.
Okay.
That's good.
Yeah. Okay. Got it. Okay. So yeah, I think there are 4 sort of areas to cover. I just want to introduce the problem statement. We obviously have heard of ZK IBC before, but we'll go a little bit deeper, and we'll kind of follow our story from there. What's really going on? So let me just switch the screen. Okay, how do I move this around? Yeah. Okay, so can I hide this somehow?
What you?
I'll just park it here. No issues. Yeah. So I just wanna, we obviously have heard of ZK IBC before, but if you see, many companies have been working on that in the past couple of months and almost more than a year actually. And while we have quite a few ZK IBC implementations out there already, some of them supposed to be production ready as well, we have really not seen anything hit mainnet. So why is that? Why, in spite of being ready, why are none of these companies actually hitting mainnet? So the reason that this has been happening is that, and this is not just true for ZK IBC, but ZK bridging as well. ZK bridging and ZK IBC have been found to be super expensive, right? So, is there any questions? Sorry.
No, I think.
Okay. Okay. I thought somebody was asking a question. No issues. So, like, if you, for example, not just ZK IBC in general, but if you talk about any ZK based products, all of them have this common problem that they require verification of a ZK proof on Ethereum, and doing that is extremely expensive right now. So if, for example, we just refresh the costs, it's right now, based on current gas price, it's going to cost you $40 to verify a single ZK proof on Ethereum. Now, if you analyze this is when the problem starts to really become very apparent. If you wanted to verify one ZK proof inside every Ethereum block, which is every 12 seconds, you will be required to pay 105 million every year just to keep your, just to verify ZK proofs on Ethereum, right? So like no one can really pay this cost. Like if you talk about, sorry, is there a question? Okay, I'll just move on. So this is kind of what the problem statement is, that it's extremely expensive to verify ZK proofs on Ethereum, and this is why ZK IBC is not on mainnet today. So that's where we really come in and start solving this problem. So we've been working on way to solve this problem, that we can reduce the cost of proof verification on Ethereum by multiple orders of magnitude. So the overview of our solution is something like this, that rather than enabling or asking everyone to submit their own proofs on Ethereum, we will aggregate proofs from, we will collect these proofs from multiple different chains and protocols, collect them together, create an aggregate super proof, and then submit this super proof on Ethereum. So this allows you to amortize the cost of proof verification on Ethereum basis the number of chains that you have participating, or any other protocols that you have participating in your aggregation network. So if you, to dig a little bit deeper, what this means is that, so you have, so let's say you try to plot the cost of proof verification per chain as you increase the number of chains that you are aggregating in the network. So let's say you have 10 chains in the network, you pay 1/10 the cost that you would have paid otherwise. So again, going back to this, so let's say $40 is the current cost. Now, if you have 10 chains in the network, each chain has to pay only $4, right? So that's kind of our solution. And it the great thing is that it, the cost per chain falls very rapidly as an inverse function of n. So once you get to like 10 chains, you have a 90% cost reduction. And once you get to, let's say 50 chains, you are going to have a 98% cost reduction, right? So again, it falls very rapidly, and 98% cost reduction is quite significant. So by the way, there are 62 Cosmos chains on mainnet right now. If you aggregate all of them, you're going to have a more than 98% cost reduction. So rather than costing 105 million, all these chains have to together pay only 2 million. All these chains have to, on an individual basis, have to pay only 2 million, collectively paying the total amount. And obviously, as you start adding more protocols in the network, the cost per chain decreases even further. So that's really the gist of our solution. Would love to take any questions at this point, if anyone has any.
No questions, I think. So
okay. So I'll just move to the product demo in that case. Okay. So let me refresh this one again. All right. So let's quickly look at this testnet explorer and what it's really showing us. So as I said, we are aggregating almost all the Cosmos chains at this point. 51 out of 62 Cosmos chains. So 62 on mainnet, 51 of them we are already aggregating. The 11 that we are not aggregating are the ones where we were hitting too many edge cases in our circuit design. So with upgraded circuits, eventually we can start supporting them as well at some point of time in future. But all the major chains we are pretty much supporting right now. So right now we collect proofs, ZK IBC proofs from these individual chains once every 1 hour, and create aggregate proof, which we call as the super proof. So as you can see, we have aggregated a total of 806 super proofs so far, which we have verified on Ethereum. And the next proof is basically due in less than half an hour. Since we are aggregating 51 chains, the cost that every single chain has to pay is basically 1 by 51. So if you subtract that from 1, you get 98%. So that's why we are able to offer a 98% gas cost reduction for proof verification for ZK IBC. If we just go to the super proof verification contract, so this is the contract where we are submitting all our super proofs, and as you can see, in the last couple of hours, one proof has really come in. So every single one of these transactions is corresponding to a super proof submission. And we have had roughly one super proof come in every single hour, which is in line with what you see over here. If you look at the timestamps, you can see that one proof is coming every hour. So if we can actually go a little bit deeper into a single proof. So there are quite a few fields to understand here. I'll go through them one by one. So the first one is obviously Ethereum transaction hash. This is the Ethereum transaction on Sepolia that verified the super proof. This total proof verification cost, this is not a proof verification cost, but this is the total cost of the transaction that verified the proof. So this includes a bunch of state updates and a little bit of other overheads as well, which is total 360K. So one proof verification is roughly 250K gas. And if there's some overhead that's happening here, summing to a total of 360K gas, which is the cost of this super proof submission on Ethereum. But if you look at the second field, this is a little bit more interesting. So as I said, we have 51 chains, and each chain has to pay only its own slice of the super proof verification. So 361K gas divided by 51 is 794 gas. So this is the gas cost that every single chain is paying for their own proof verification. So as you can see, it's $1.23. So from $63, we came down to $1.3, which is a significant reduction. So as you can see, if you look at each of these chains that we have aggregated, you will see that each one of them is just paying a small slice of the overall proof verification cost, which is 7,094 gas. Looking at the rest of these, let's say these particular fields. So basically, these are the fields corresponding to the state transition. So let's say we proved the consensus of Cosmos chain, then the on-chain state, the on-chain like-kind state that we were maintaining for Cosmos on Ethereum got updated from a certain height to the new height, which, if you understand how like-lines work, the proof is essentially validating, attesting all the blocks that came between this block height and that block height. So standard like-line stuff. So this is just telling you how many blocks you have really jumped and what is the old state and the new state. So that's standard like-line stuff. But if you look at this particular column, this is where things actually get pretty interesting. So this is the individual proving time. And if you notice, there's another entry here, which is called a total proving time. So let's try to understand what that is. If you go back to the documentation again, so the way we construct our prover infrastructure is that we have a bunch of prover chains that are running in parallel, right? And each of these machines is proving one single chain of Cosmos. So if you go back here, just a second. So these proving times are corresponding to the proving time for each of these machines that are generating proofs for the chains. So, and if you look at this total proving time, this is the end-to-end proving time for the entire process. Now, as I said, so there are, if you look at the pipeline, there are 3 steps. So one is the individual proofs from individual chains getting proven. Then we have the aggregation engine, which is putting all these proofs together to create the aggregate proof. And then you have the final step of Groth-16 reduction, where we take the aggregate proof and make it even smaller using Groth-16 reduction. So if you look at the parallel proving time, which is 689 seconds, this is the maximum time taken by the parallel proving machines for each of the chains. So if you go through the proof generation time for each of these chains, the maximum of them will be 684. So since these are running in parallel, basically we have to wait for the machine that takes the maximum amount of time to generate the proof. So that's why we have 6 parallel proving time is as the max of the proof generation time for individual chains. So that's the first entry. Second one is the aggregation, which I just explained. It's the one we're putting everything together. The final step is the Groth-16 reduction time. We have a little bit of network latency as well, which is not really represented in this one, but it's like less than a couple of seconds. So it's kind of all right. So that's really the explorer for proof aggregation testnet for Cosmos. The next step for us over here is to go ahead and start integrating with some of the existing ZK IBC builders. Union, for example, is working very aggressively on that. Composable also recently issued an announcement. Succinct is probably working on that. Polymer was working on that. So our goal is to really see, we believe that ZK IBC didn't happen so far because of the high verification costs. And with this, we have brought about very significant cost reductions. And I think the technology is really ready for hitting mainnet at this point. That's what I had to present. Would again love to take any questions.
Yeah, thank you for the presentation. I guess, sorry, I didn't realize, Adi, maybe if you already raised your hand, you can go.
I had a question about what explains the difference in proof creation time between Cosmos Hub and the other chains. Why is the hub so significantly higher?
Yeah. So the biggest overhead for proof generation time is the number of validators that we need in order to achieve 67% voting power. So if you have a bigger validator set, and if you need a bigger validator set to prove 67% voting power, you are going to take more proving time. Does that answer your question?
Yep.
Aditya, yeah.
Yeah, thanks, Corbett. Yeah, so my understanding, it looks like the ZK mainly is being used for the light client consensus part of the light client. For now, once you get the root hash or like the app hash of the latest height, are you still using, is the plan to still just do Merkle proof verification directly on Ethereum?
Okay, so I just want to point out that our goal here is to really provide a proof aggregation layer. This is a question for somebody who's actually trying to build a full protocol to Ethereum. So somebody like Union or Composable, for example, who would really need to answer this question, that how exactly do they want to structure it? We will simply make ZK proof verification cheap for you so that whatever your protocol is, it's practical and cheap enough to run on Ethereum.
Yeah, no, I guess it's like, yeah, so this is, I guess, an aggregation of the header verification, right? So the
Okay, yeah, yes, correct,
which makes a lot of sense. But then in IBC, once you have that header verification, you've added the I think you have here in one of your pages in the Explorer, like the actual consensus. Yeah, so you have this block hash, right? So IBC has this first step, which is to verify the consensus in order to add this block hash in the first place, which is what you're using the ZK proofs for. But then after that, to verify like a particular packet or something like this, we use a Merkle proof against this block hash.
Yeah,
right?
yeah, correct.
Also
So,
going to be Merkle, yeah.
Yeah, so basically once this root hash makes to the chain, anyone who wants to validate the transaction itself can just follow the Merkle part to the root hash.
Okay.
Yeah. Or you could actually push that logic inside the ZK circuit itself. And in that situation, we would be directly executing the state update on Ethereum mainnet, which would obviously reduce the gas cost very significantly. So in that case, let's say Union decides to do that, they can push that logic inside the circuit and give us a proof with not just including the header verification, but also the transaction validation itself. So that would also be supported in our overall design, because we are not specific to a given use case. We are use case agnostic in terms of what our proof aggregator can aggregate.
Got it. So it's something that your users might decide.
Yeah, correct.
Thanks.
Any more questions for Garbit?
Yeah.
So maybe I have a question. So then the idea is that now you will partner with these other teams so that they can build on top of the infrastructure that you have built here with the super proofs. Is that correct?
Correct.
Okay. And what are the next steps? Because you're running this on mainnet, right? Ethereum mainnet.
No. That would be too expensive. This is on Sepolia right now.
Okay.
The chains that we're aggregating are on mainnet. So these are mainnet chain headers, but proof submissions themselves are happening on Sepolia.
So what are the next steps to bring this to mainnet?
Yeah, so there are two things that we are working on. So the first one is aggregating more protocols. So rather than just aggregating ZK IBC chains, we are planning to start aggregating other use cases as well. So for example, let's say you are a privacy protocol on Ethereum. You also want to submit a proof on Ethereum. So we will aggregate your privacy proof as well. The reason for that is because when we integrate their proof, the cost for Cosmos chains also go down, right? I hope you are with me on that the more people join this network, the lower the cost per use case and per user. So ideally, we want to not be use case specific, but aggregate everything possible rather than just ZK-IBC. So that's step number one for the engineering team, that we just keep on aggregating more protocols. Second
Okay.
step is obviously to get this thing audited and ready for mainnet, so that if there's a team who wants to go mainnet, we are ready for them. Yeah.
Okay, cool. And then, so how many chains do you think you need to aggregate to make it like economically viable to reduce the cost?
Yeah, I think we are quite close to it. We ideally want to do something like 99% plus. Cost reduction, we are already at 98%. So we just need to find a bunch of more proofs to aggregate in order to bring this cost down. Yeah.
Okay, great, thanks.
Yeah, and I had another question, Garvin. So, yeah, as you said, I understand that as you add more and more chains to the aggregate proof, the cost per chain goes down. But who's in your mind incentivizing this? Like we've already had a discussion on incentivization. Like, is it in your head like Cosmos Hub will pay this $1.23 to Electron
No.
Or
So basically, if you step back, right, a lot of people are already verifying proofs on Ethereum. Not necessarily ZK IBC folks, but there are quite a few rollups, privacy protocols, ZK coprocessors, ZK bridges that are already submitting proofs on Ethereum right now on mainnet and verifying these proofs. So these people already have a desire to pay these costs. So our strategy will be to really start reducing the costs for them and get to a stage where ZK IBC itself becomes viable. So for example, if let's say Union wanted to do that, on the day one, we are offering them a significant gas cost reduction. And once you start offering the gas cost reduction, a lot of people can sort of come in really to start using this because it has become viable. And once a lot of people start using it, the cost becomes so low that it just makes sense to continue to use it. I'm sorry, what was your question again? I think I digressed a bit.
Yeah, the superproof submitter is going to be, regardless of how many chains are being aggregated, the person who submits the superproof will have to pay like what, $63 every hour to the mainnet, right? So I understand that every single chain behind that superproof is getting a very cheap cost, but how do they compensate that superproof submitter who's still paying a very high cost, presumably?
Yes. So we basically plan to pass on these costs to the customers, right? So let's say we are running a prover, or let's say you are running a prover, right? We have an open prover network at the end of the day. So let's say you are running a prover, you submit a proof, and you pay this gas cost. Now you will charge this cost back to all the people who gave individual proofs to you, right? You have to find a way. There has to be a gas fees mechanism inside this prover infrastructure that this gas cost can pass on to the individual. So the individual, let's say Union was integrating this, Union and their users would pay this cost, right? But they would obviously pay a small slice of it, such that, and obviously all the people who are participating in the network are also paying their own slices of it. Together, it sums up to the super proof verification cost.
Yeah. Okay.
Yeah.
Got it.
Yeah.
Cool. Any more questions? All right. If not, yeah, thanks a lot for the presentation, Garvit. Yeah, we still have maybe like a few more minutes if somebody has another topic to discuss. If not, we can wrap up. Thank you everyone for joining. Yeah, thanks again, Garvit, for the presentation. We'll share the recording.
Thank you so much for having me.
Thank you, everyone. See you next time.
Thanks, Garvit. See you guys.
Thank you. Bye-bye.